Hi, this will be a video on learning to simplify powers of I as explained in the first video on imaginary numbers. So with this slide, it says over powers of I, we actually have this circle going around. And if you take a look and notice, we have I, then I squared, then I cubed, then I to the fourth. These arrows demonstrate that it actually becomes a pattern. And what this pattern represents is the powers of I as we increase beyond powers of 4. So this would be I to the first, second, third, fourth, and actually as we increase powers of I, we end up getting the same value. So when we increase from I to the fourth to I to the fifth, it's the same value as I to the first. I to the sixth would be the same value as I squared, which would equal -1. So I to the 7th, 8th, 9th, 10th, 11th, 12th, 13th, 14th, and so on. It actually continues to repeat. So what I really want you to remember is that we have to memorize this pattern, all the powers of I, from I to the first to I to the fourth. And there's an easy way to memorize these that I teach called I1, I1. So if you take a look at this, we have I to the first, I squared, I cubed, and I to the fourth. If you recall when you were a little kid and you won, you might have said, I won, I won. And that's actually the pattern of these values from I to the first down to I to the fourth. So I won, I won. But remember that the 2 in the middle are going to be negative. So I suggest that every time you begin simplifying powers of I, you jot this down. I squared, I cubed, I to the fourth. Then I1, making sure that the 2 in the middle are negative. Down here you can also see that it says that we can also take our exponent and divide by 4. Since this repeats after a pattern of 4, if it was I to the 5th power, then I to the 5th power, if we divide that by 4, it's actually I to the 1 1/4. So that numerator representing a remainder. And if we have a remainder of 1, our answer would be I. So that makes sense because I to the 5th is the same as I to the first, so it would equal I. Another way I like to think of it is to think about money. Since we're going to divide by 4, if I had a power of 5 and I divided by 4, I would actually get a remainder of 0.25. So I'm going to put up here that if we get a remainder of 0.25, then it's equal to I to the first. If we increase to I to the sixth and divide by 4, we actually get a remainder of 0.5, so we can think of like 50 cents. And then if we increase to 7 and divide by 4, we get a remainder of 0.75. And then if we were to go to I to the 8th, then 8 divided by 4, it would actually divide evenly. So that means we can think of like no remainder. So think about like $1, right? So 25 cents, 50 cents, 75 cents, $1, meaning, like if we thought about it like $1, it would divide evenly, so 0.00. So we're actually going to apply this as we move on and extend to simplifying powers of I that are pretty high. So the first thing we always want to do if you're asked to simplify something like I to the 23rd is for each one of these we're simply going to divide our exponent by 4. This will give us the remainder value that we need to determine its equivalence here, and thereby knowing the correct simplified value. So if I take my exponent of 23 and divide by 4, I get 0.7. Let me put it on the screen, 0.75. So if you can see that. Sorry, it's a little bit bright. 23 divided by 4 is 0.75. So I'm going to look back up here to my chart, and 0.75 actually leads me to I cubed, which has a value of -I. So that means that I to the 23rd is also -I. If we're finding the value of I to the 2006th power, 2006 divided by 4 has a remainder of 0.5. So that means I'm going to look here at my list, 0.5, and go, oh, that's the same as I squared, and I squared has a value of -1. Therefore, my answer would be -1. So that's really what I want you to do is kind of think, well, if I divide these, what do I get? So this was 0.75. This was 0.5. If I divide 37 by 4, we get 0.25. So we'll put up here 0.25. 828 divided by 4 is 207, so we see no decimal value, meaning it doesn't have a remainder. It divides evenly, so I'll put 0.00. Then we can always just go back to our chart here and say, okay, well 0.25 is the first one, so that's I. And if we get no remainder, that means it divides evenly and it equals 1. Okay, so we can kind of make one up. So if we did I to the 931st power, we can make these up to practice. So if we type in our calculator 931 divided by 4, we get 0.75. 0.75 is the third one, so that's I cubed. Remember, I1, so that I is the one here in the middle that's negative. So when I divide by 4, I got 0.75, so my answer is negative I. And that's as simple as it is. That's all there is to it. Now, the reason why we use these is there's other things that we need to be able to do other than just simplify i's with large powers. So I'm going to go through 3 examples that you should add in your notes here to help you. We're still going to use the same concept of dividing by 4 to help us simplify this. So notice this expression is I to the 17th plus I to the 28th plus I to the 33rd. I'm going to first divide all of my powers by 4 and write their little remainders up here. No remainder, so 0.00. 33 divided by 4, 0.25. And then think back to your I1 chart. So again, I1. But remember that these two are negative. So this was your I to the first, I squared, I cubed, I to the fourth. It's a good idea to write it over and over each time. That way you learn it. And then it was 0.25, think increasing from a quarter, 25 cents, 50 cents, 75 cents, $1. Divides evenly. And then we can replace each of these values with the simplified value. So I to the 17th, because it had a remainder of 0.75, would be I. The next I to the 28th did not have a remainder, so that was just 1. And I to the 33rd, when we divided by 4, we got 0.25. So that's just equal to I. At this point, when we combine when we simplify expressions, we combine like terms. So we actually, even though I is a number, we simplify it the same way we would a variable term. So the same way if we had x plus 1 plus x, that we would get 2x plus 1, we do the same thing. However, we always want to write the real number first and the imaginary part second. So I plus I is 2I, and then we put 1 first because that's our real number value. All right, and that's done. The next one we'll try is when we have a coefficient here. So here we've got 6I to the 10th power plus I to the 22nd power. Again, the first thing I'm going to do is take my exponent and divide by 4. When I do that, I get 0.5. So I'll put up here a 0.5. And 22 divided by 4 was also ended in 0.5. So because I got 0.5, I'll look back here at my chart. 0.5 here means that my value is negative 1. So this means I have 6 times negative 1 plus negative 1. And then it's just a matter of simplifying. So this is negative 6 plus negative 1. Or you can think of it as negative 6 minus 1, which is negative 7. And we're through. The last one involves using your laws of exponents, specifically your power property, which says that if you raise a power to a power, you're going to multiply your exponents. And if you aren't real clear on that, please remember that anything squared is just representing repeated multiplication. And then that would be 3i to the 7th times 3i to the 7th. Recall that would be 7 i's. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. You do not have to show the work each time. I'm just showing you what it means. This means we have 9i to the, and if we counted up all our i's, there would be 14. But because of that, we know that really what we have to do is multiply our exponents when raising a power to a power. So now we're down to simplifying the expression 9i to the 14th. Again, we want to take our exponent 14 and divide by 4. So 14 divided by 4 ends in 0.5. I1, 0.5 is -1. So this is 9 times -1, which is -9. And we're all done. So hopefully you've learned in this video how to simplify with powers of I. Please remember to memorize this pattern here using I1. That will help you simplify every time you have powers of I in an expression. Thank you.